Hello friends, this video Limits and Derivatives Part 2 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched Part 1. Limit is used when we want to find the value of a function near to some value. We want to find the value of a function near to some value. I'll take an example. For example, this is the graph. This is a graph. fx is equal to x square minus 9 by x minus 3. So if you plot this graph is nothing but, if you see x square minus 9, I can say x plus 3 into x minus 3 and this by x minus 3. This is fx. So when x is not equal to 3, I can cancel this. So this becomes fx is equal to x plus 3 when x is not equal to 3, and this becomes the whole thing, that is x square minus 9 by x minus 3 when x is equal to 3. This is the equation we have. Now let's plot this. X is equal to 0, this is not equal to 3, y is equal to 3 plus 1, that is 4. Correct? X is equal to 1, 3 plus 0, that is 3. X is equal to 1, y is equal to 3 plus 1, 4. 4, x is equal to 2, y is equal to this one. X is equal to 3, this is 0, this is 1, 2, 3, 4, 5, right? And this is 1, 2, this is 3, this is 4, 5. Similarly, x is equal to minus 1, you get value of 2, you get this is minus 1, x is equal to minus 2, you get 1, x is equal to minus 3, you get 0. This is the graph you get, but x is equal to minus 3, this condition is not true. X is equal to minus 3, you put this value, you get x square minus 9, that is 9 minus 9, 0 by 0, it's infinity. So this is the x is equal to minus 3, this value is not defined. So graph will be of this form actually. Till x is equal to 3, this is defined, but x is equal to 3, it is not defined. This will be the graph. So here if you see at x is equal to 3, this value is not defined. So if I want the value of f of x, that is f of 3, that is nothing but not defined. But if I want to find the value very near to 3, that is 2.99999, this value, or 3.00001, here if you see the value at 2.9999 is not infinity. Also the value at 3.0001 is not infinity, because in that case we can use this equation x plus 3. So if you see value at 2.99999 is equal to 2.9999 plus 3, because we can use this equation. So this becomes 5.99999. Similarly, the value of equation at 3.00001 is equal to 3.00001, whatever, how many zeros I put here, plus 3, that is 6.00001. So if you see the value of this function very near to 3 is different from the value of function at 3. Correct? Both are different. The value of function very near to 3 is either 5.99999 or 6.00001, or we can say that is almost equal to 6, right? The value of function very near to 3 is 6, but the value of function at 3 is what? Undefined. So there is a difference. There is a difference between f of 3 and f of near 3, that is f of 2.9999 and f of 3.00001. There is a difference. So such kind of study we do in limit. So to find the value of this function very near to 3, we use limit. Correct? So the notation is something like that. We'll say limit x is near to 3 and we say fx. This is the notation we used for limit. Since in this case we had 3, so we have used 3. In general formula we'll say a can be any value, 1 or 2 or 3. So in our case it was 3, so we have put 3 here. This is the notation for limit, and limit is used only when we want to find the value of function very near to 3. This is one example where the value of the function very near to 3 is different from the value at 3. But if you, let's suppose if you take the value of value here 0 or 1, let's take 1. So here f of 1 is 4, 1 plus 3 is equal to 4, and f of value very near to 4, 1 is suppose 1.001, that will also be almost same, that is 1.0001, sorry, 1 more 0 plus 1 plus 3, that is 4.0001. So here if you see 4 and 4.001 are almost same. If you take the negative side also, the right side also, left side also, that value you get 0.9999, f of 0.999, that is 0.9999 plus 3, that is 3.9999. So this value is also almost similar to equal to 4. So it's always not that the value of function very near to a value and the value of function exactly at that value is different. Here if you see function value at 1 and near to 1 are all same. But in case of 3, the value of this function at 3 and near to 3 are different. The point I'm trying to drive here is limits are used when we want to find the value of the function near to some value, not exactly at some value, but near to some. So let's define the limits once again. So we have something called left hand limit and right hand limit. I'll explain. For example, this is a function. So let's suppose this is the same function we'll take, or we'll take different function. So let's take one function which says fx is equal to let's suppose 5 when x is not equal to 2, and fx is equal to infinity when x is equal to 2. Or let's suppose this is fx is equal to x. Fx is equal to x when x is not equal to 2, and fx is equal to infinity when x is equal to 2. So this function will be something like this: x is equal to 0, y is equal to 0, x is equal to 1, y is equal to 1. This is 1, this is 2, it's minus 1, minus 2. But x is equal to 2, this is infinity. This value is not defined. So we'll have function like this. This will be the function. The straight line. Yeah, this will be the value of the function. And this is this function. This is the function where fx is equal to x when x is not equal to 2. So this is like this. And fx is equal to infinity when x is equal to 2. So at x is equal to 2, this is not defined. Now, the left hand limit is what is the value of this f2, that is f2 minus. So I'm talking about 1.999. So when I'm taking left hand limit, so I'm talking about something f of 1.99999. That is, when I'm trying to approach this function from the left hand side, what is the value I get? Similarly, when I'm talking about right hand limit, I'm talking about value something of this form 2.0001, because when I'm trying to approach this function from right hand side, what is the value I'll get? So this is the typical example of left hand limit and right hand limit. Left hand limit is, this is the function, and at f is equal to 2, I'm trying to approach f is equal to 2 from left hand side, that is value of f is equal to 2 near to 2, but from left hand side, that is 1.999 or 1.998 or 1.901, anything that is less than 2 but near to 2, that is left hand limit. Right hand limit is, for f of 2 is anything that is near to 2 but greater than 2, that is from right hand side. So that is f of 2.001 or 2.002 or 2.0015 also, any value that is near to 2, anything in this range, anything that is near to 2, and that is from the right hand side. And for left, anything that is near to 2 from the left hand side. So you got the difference, left hand limit and right hand. Left hand limit of a function at a is f of a, that where a is near to this value. Similarly here, for example, and for in this case we'll write limit of x is equal to 2 minus, right, and fx, that will be nothing but f of, let's suppose, 1.9999. This is nothing but limit of 2 minus fx. Similarly, when I say limit of x of 2 plus and fx, this is nothing but f of 2.0001 or any value I can take, 2.0002 or f of 2.0015, any value that is near to 2 but from the right hand side. These values are nothing but limit of x 2 plus fx, and this guy is limit x 2 minus fx. So this is called left hand limit, where you try to get the value of the function the left hand side, anything that is near to this a, and here a is 2, anything that is near to a from the left hand side. In right hand limit, you try to find the value of this from right hand side. Also please note, in case where left hand limit is almost equal to right hand limit, that is left hand is equal to right hand, almost right hand, then we say that limit exists. For example, in this case, left hand limit is 1.9999 and right is 2.001. Both are almost same, both are almost equal to 2. So we can say that left hand limit n is equal to right hand limit, and that is equal to 2. So in such case, limit exists. In case where the left hand limit value which we get is not equal to right hand limit value, so in that case we say that limit doesn't exist. We'll show you some examples where the left hand limit will not be equal to right hand limit, and in such case we say that limit is not defined for this function at that point. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.